Hello. Now, let's continue. Find all the solutions to sine 2 theta is equal to minus root 3 over 2 in the interval 0 to 360 degrees. So we're dealing with degrees because that's the interval type that they've given us. They could have also said 0 to 2 pi or 0 to 4 pi or 0 up to 720 degrees. So what we're going to do is find the general solution to this. We're going to get these equation type things, theta in terms of an angle plus number of rotations, and we're going to use these formulae to find all of the solutions in a particular interval. So find all of the valid solutions in a particular interval. So if you find you're asked for find all the valid solutions, all you're doing is getting the general solution and then subbing in values of n to find specific solutions, and we stop when we get outside of the interval we're asked about. Now let's get into it. Same steps as always. We're going to find our reference angle for our 2 theta. So we're going to treat this like it was just sine of theta was equal to minus root 3 over 2, and then at the end we're going to divide everything by 2. If it was 3 theta here, we would divide everything by 3. Now, we have reference angle, and we are looking at sine. So sine is opposite over hypotenuse. So we draw in our model triangle. We've got our alpha, and this time we have opposite. It's root 3 over hypotenuse of 2. So our cos of alpha is going to be root 3 over 2. Alpha is going to be, take inverse cosine of both sides, and we're going to have cos inverse of root 3 all over 2 is equal to 60 degrees. And then we are going to use the fact that we know that this is sine is minus. Well, what quadrants does that happen in? Well, sine is the y component of is the y coordinate, I should say, when we're going around our unit circle. So where is that going to be negative? Well, it's going to be negative underneath the x-axis. So we draw in our unit circle, and we're dealing with 60 degrees down here and 60 degrees down here. So we've got 60 degrees here, 60 degrees here. We're going down 60 degrees in both cases, so I'm going down into the 3rd quadrant and the 4th quadrant. And I know I'm doing that because I'm looking for where my y values are going to be negative. My sine function gives me the y values in my unit circle. So where is sine negative is where my y values, my y coordinates of those 2 points are going to be negative. So our different values for 2 theta then, let's break this up. We have 2 theta would be equal to 180 plus 60 is equal to 240. The other value for 2 theta, the other possibility in quadrant 4, so this is quadrant 3 situation, quadrant 4 situation, would be 60 degrees back from 360. And that's what our 2 theta is. Let's find the general solution for 2 theta. 240 plus 360n. So 240 gets us to there, and rotating around a further 360 degrees or a further 720 degrees will bring us back around to the same point again. So if we are at a particular angle and we go around a particular number of complete rotations, we get back to the same point. That's the core idea of our general solutions. 300 plus 360 n, and I'm dealing with 360n as opposed to 2 pi n because I'm dealing in degrees. Now divide both sides by 2. And we bring this down. Theta is equal to 120 plus 180 n, and theta is equal to 150 plus 180 n. Those are my general solutions for theta. Now, what I'm going to do is use these general solutions and put in my values for n. So n is 0, n is 1, n is 2, n is 3, up until I end up with thetas that are outside of this range, outside of the 0 to 360 degrees range. So let's set n is equal to 0. We start with n is equal to 0 because we know that theta is equal to 120 should be a valid solution. So we don't want to lose that solution. So it's important that we remember that n is equal to 0 is our first angle. Then we get 120 plus 180 times 0 just gives us 120. So theta is equal to 120 is a valid solution. And when n is 0, we have theta is equal to 150 plus 180 on 0. All right, I'm not drawn very well. Times 0, so we just end up with theta is equal to 150. So 120 and 150 are valid solutions, but we can keep going. They're inside our range. So let's see if we can get another bunch of solutions that are inside our range. So when n is 1, we have theta is equal to 120 plus 180 on 1. We add that up and we get 300 degrees. And we do likewise, n is equal to 1. So theta is equal to 150. We're going from our general solution plus 180 on 1, we get 330 degrees. That's still inside our range, so let's keep going. If you were confident that the next one was going to go outside because we're adding on another 180, which should bring us outside of 360, that's fine. But as a general method, you just keep going until you get outside of your range. It's a perfectly fine way to do it. So theta is equal to 120 plus 180 on 2 is equal to 480. Now that's outside of our range, so we don't include it. And theta is equal to 150 plus 180 by 2 is equal to 510, which is outside of our range, so we don't include either of those solutions. So all of the valid solutions for theta are going to be 120, 150, 300, and 330. It's best practice to put all of these nicely in order from smallest to biggest. It's not technically a requirement, but it's a good idea, particularly if they want you to do anything with it. So those are all of the solutions to this function over this interval. And that's what we need for the general solutions of trigonometric equations.